lesson is about special lines in triangles, and it goes along with Module 1, Lessons 29 and 30 in Engage New York. In this lesson, we'll cover 1, CCRSM standard, and prove that the segment joining the midpoints of two segments of a triangle is parallel to the third side and half the length of the third side. The other proof about medians of a triangle we will do in our next video. Let's get started. Before we get into Engage New York, I want to show you something I made in GeoGebra. I first constructed triangle ABC, and then I constructed the midpoint of AB, and that was point D, and then point E is the midpoint of AC. And so what I got was segment DE by connecting points D and E, which is called the midsegment. And I like the term midsegment because it is in the middle of the triangle and connects the midpoints of two of the sides. Now watch as I move point C, or move this around. Some things happen with the midsegment and the third side, meaning this segment and this segment. The most obvious thing is that it stays parallel to the third side. But one more thing to notice is that the length of the midsegment will be half the length of the third side. Now I know that we see that through lots of examples by moving this around, but one of our standards is to prove that that is true. And so in Engage New York, it walks you through the proof, which I will warn you now is a pretty elaborate proof. On the left, we have the picture from page 160, and I will draw on the diagram as I go through this proof. I want you to do the exact same thing. On the right is the steps in the proof from page 161, which will continue on to page 162. This proof starts off with a given. We're given that segment XY is a midsegment of triangle ABC. So I will draw in the midpoint of AB and call that midpoint X. I will draw in the midpoint for segment AC and call that point Y. And then I will construct the following using this hint. I will draw triangle YGC according to the following steps. I will extend XY, here is XY, and I'll extend XY be the same distance as XY. So this length will be the same as this length. I'm extending that the same distance and creating a point called point G. And I'll also connect point C and G. So it may look strange to you, but there's a reason behind that. So the first step in our proof is talking about the relationship between XY and YG. Well, they're congruent by construction. That's how they asked us to make it, and so I did, and I constructed it that way, and so that's why it's true. Number two, what is the relationship between angle AYX, this angle, and angle GYC, this angle? Well, they're congruent because they're vertical angles. Third, what is the relationship between AY and YC? Well, they're congruent because Y is the midpoint of AC. Okay, number four, we are looking at this triangle right here and this triangle right here and saying, hey, I have side, angle, side, side, angle, side. They must be congruent by side, angle, side. Now I'm going to scroll up. Number five, what is the relationship between GC and AX? Well, GC is right here, and AX is right here, and those are corresponding sides of the triangles that I just proved to be congruent. So they are congruent because corresponding sides of congruent triangles are congruent. Number 6, since AX equals BX, what other conclusion can be drawn? Well, both GC and BX, the lengths of those segments are both the same as the length of AX, and so they must be congruent to each other by substitution. Number 7, what is the relationship between the measure of angle AXY, that's right here, and the measure of angle YGC? Well, those are also congruent because these are corresponding angles of the two triangles that I just proved were congruent by SAS earlier. Number 8 says, based on number 7, what other conclusion can be drawn about segment AB and segment GC? Well, this one's a little tricky. If you look at this angle right here and this angle right here, and you think about this and this as two lines, and about XG as a transversal, then you would say that these two angles are alternate interior angles, right? You may not have seen that before, but they are alternate interior angles. And if the alternate interior angles are congruent, then the lines must be parallel. I will draw on the diagram. And then I will look at this quadrilateral right here. Notice that these two sides are both parallel and congruent, and we proved before that that is a property for parallelograms. And so this quadrilateral down here must be a parallelogram. And because parallelogram BXGC is a parallelogram, that also means that this segment must be parallel to this segment because that's how we define parallelogram. And what that means is that segment XY, or the mid-segment, must be parallel to segment BC, the third side. And I'll box that because that is one thing we were asked to prove in this, that the mid-segment is parallel to the third side. Number 10 says, based on step 9, what is the relationship between XG and BC? Well, they're equal because a parallelogram has opposite sides that are equal in length. Next, in number 11, since we constructed YG to be equal to XY, then XG, this whole length, must be twice as long as XY. Next, I will substitute BC in for XG and say that BC is equal to 2XY by substitution. And then, dividing both sides by 2, I find that XY is equal to half BC, which is the second thing we were asked to prove, which is that the mid-segment is half as long as BC. So all those steps become the proof to prove that the mid-segment is parallel to the third side and half the length. This lesson was about special lines and triangles. We talked about the mid-segments, and two properties of mid-segments mean that they're parallel to the third side and half the length. Thank you for watching.